Well, howdy, my name is Arya. Welcome to my video. In this video, we're going to be doing part 4 of my build series for building this CNC machine. Right now, we're going to be focusing on the electronics. I know there's a lot of fun stuff over here. If you watch part 1, 2, and 3, you've been kind of chopping at the bit for part 4. I want to kind of ignore all of that stuff that's exciting over here. We're going to focus on the electronics that's right behind me. It's going to be more of a technical video, less of a build log. I apologize for the video being a little bit late. I've been kind of sticking to 1 a month videos typically. This video has taken me a lot longer. As I said before, I don't know what I'm doing. So this electronic part has been really complicated for me. I've been trying to gain a lot of information and do things as safely as I can. I think I've done that. And even though this video is going to be kind of a tutorial format, I want to put a disclaimer out there that it is not a tutorial to do this the safest way. There are a lot of people out there that do this for a living or are experts in the field. I am by no way either. This is the safest and best way that I have found for me to do. If you want to attempt this yourself, I strongly recommend that you ask a professional or someone in the Discord who is a professional how to do this. I think I made this introduction as long as I could without people trying to kill me. So without further ado, let's get right into it. So here we are in front of the enclosure. I think the best way to do this is I will go over kind of what's on the front here, what's on the inside, how it all is wired up, and then what's on the top as far as the panel connectivity goes. If you guys are interested in anything I purchased, all these parts are all on my Amazon affiliates link in the description below. It really helps out the channel by just giving me a little bit of commission. It doesn't cost you guys anything extra. All right, with that said, let's get into it. So the enclosure that I have, starting out with just actually what it is, it's a 24-inch by 24-inch by 8-inch deep enclosure, all metal. I got it on Amazon. It is fantastic. I absolutely love it. It came with a metal panel that you can drill connectivity stuff into. I did not have a big enough drill to drill all these parts, and some of them are kind of weirdly shaped, as you'll see. So my idea is I'm going to CNC it later. I just 3D printed it. This 3D printed panel that I have up here, I will put the link to the Thingiverse that I uploaded this. I printed it in 3 parts, as you'll see later on, because it is kind of big, but we'll get into that. So as far as the front panel goes, I wanted to put as much that I needed to have on here. This is the side of my machine, so I'm not going to really be accessing this too much. I have a 120 volt emergency stop and a 240 volt emergency stop over there on that side of the enclosure on the front, which I'll show you in a second. As far as the connectivity and the interface I have on here, I have the VFD controller right here. I have a momentary on, momentary stop, and I have these aviator switches for the water pump, for the shop vac, and I'm going to do this one for the air compressor. This VFD plate that I use to mount the actual VFD display is from Logan in the Discord, I believe, and I just printed it out and just hot glued it into the slot that I cut out of this front panel. With that said, we can open this up and take a look at what's inside. Something I really like about this case is that these little flip switches, I guess, unlock it. And then if you look on the inside here, sorry for the noise, it has rubber insulation, so everything's weatherproof, which I really like. I guess it's not weatherproof, I guess it's waterproof as much as it can be. I don't think it's 100%, I think it's IP67, I want to say. Don't quote me on that. I'm guaranteed I ruined that rating when I installed the front panel stuff and cut into it, as well as the top panels that I 3D printed. But again, we'll get to that in a bit. Before I start touching anything and doing anything in here, I do want to give a really quick disclaimer. When you're dealing with high voltage and high amperage, you really want to be careful with what you're doing. I had no experience with high voltage electronics going into this at all. The highest voltage and amperage thing I'd ever done is a 3D printer, which is 24 volts at maybe 4 or 5 amps. So, and even that I was still very careful. When you're getting into high amperage, high voltage here, you can really do yourself a lot of harm and serious injury and maybe death if you do it incorrectly. So when you open it up or touch anything, please make sure you're not touching live wires or live high voltage. It is seriously dangerous and can be life-threatening. So please be careful. What I did here, obviously, when we're touching this and I have my hands in here, this is totally disconnected from power. There is no power at all feeding into this. It's unplugged from the wall. I'm not relying on any of the off switches at all before I open up and touch inside here. So that's an added layer of safety that you should definitely be aware of. Another disclaimer is that I'm going to show you exactly what I did and how I wired up my enclosure, but I really want you guys to understand that I am by no means an expert and I really don't know what I'm doing too much. I did my best to follow all the safety guidelines and all the protocols that I could read online, and I got tips from in the Discord. But I guarantee you there's someone who handles high voltage electronics, or is an electrician, or someone who actually knows how to build these way better than I do and can do this looking cleaner, safer, and all around better. That being said, this has worked for me so far. I haven't died yet, and it has powered the CNC just fine. I try to implement as many safety features as I could. So I think I have 3 stop buttons, e-stop buttons, or just latching on and off buttons, as well as this contactor, which we'll get to. So overall, I think it's pretty safe. But again, please be super careful. There are a lot of stories of people just clicking, wiring something incorrectly, or they're not aware of a wire and it shorts something on metal and they touch it and they electrocute themselves. So please be really careful when you're dealing with this, and give electricity the respect that it deserves. With all those disclaimers out of the way, we can jump right into it and go into what is actually in this enclosure. I'm going to follow the flow of power as best I can. I think that's the most logical way to do this and show you guys what's going on here. So with that said, we can jump right into it. So the first thing that I have feeding into this enclosure here is I have 120 volt and 240 volt flowing into this. I am in the US, so what that means is my 120 volt is typically what you'd anticipate, you plug stuff into the wall, and the 240 volt is basically both phases that are pulled into your house. I did not wire it up into my wall. I actually did not feel safe doing that, going to my wall and touching the sub panel. So I actually hired an electrician. It was super easy, super affordable. I think I paid like $300 for it. And they came in, and I had an actual 240 volt outlet installed in my garage. Really easy and simple, and I didn't have to touch any live wires or deal with the actual in-house electricity. The way power flows here is I have 2 plugs on the top, and again, we're going to look at the top panel here afterwards. But I have right back here, you can see I have a 120 volt outlet right here, flanged, and I have a 240 volt flanged outlet in the back there. The 120, I organized everything as much best I could. So black for 120 is neutral, the red is hot, and the green is being used for ground. All the ground terminates here at this bus bar, so everything's grounded, both on the 120 and on the 240, all to this bar. The enclosure is grounded, all elements are grounded to the same place, as well as the door of the enclosure. I'm not sure if you guys can see, but over here I connected the door via these little nut and washer. You need to make sure that everything terminates to the same ground, aka that if you have what I'm doing here, that the 120 volt and 240 volt grounds are continuous and are the same ground at the sub panel. So power flows down from this 120 volt and feeds down, as you can see, to these wires and goes to my 120 volt e-stop. That is the first stop it takes. That is the first thing I use to make sure that power is flowing the way I want it to do. When the e-stop, it's a magnetic coil, which we'll look at. When it is turned on, power then can flow back into this enclosure, and it flows down into this panel over here. So when power flows into these 2 bus bars, obviously you can see the black is neutral and the red is hot. What happens here is that then it powers a couple different things. So the first thing that it will power on here, or I guess one of the things that it will power, is the actual momentary switches on the door. These control how everything else turns on in my enclosure. So power will flow in, these will light up, and I'll show you a light sequence or a start sequence in a moment. These will both glow green and red, and I can click on this and it will engage the contactor, or I can click on this and it'll turn off the contact. That main bus bar that we described back here also powers pretty much everything on the front that you can see. These cables all are 120 volt, and this just acts as a simple contact on and off switch to let power flow from power in to power out. These power outs go various places. I have 2 outlets up top here that I can use, and the last one obviously I haven't wired up yet, so I gotta figure out where I'm gonna wire that one. The other thing that these terminal bars power is this 120 volt to 24 volt power supply. The power supply converts the 120 to 24 volt at 5 amp DC, and this powers a number of things, including the LEDs that I get to install, the Mesa board, the contactor, as well as all the limit switches, which is an important factor that we'll talk about later when we get to the Mesa board. When power flows from this to the various stages, the one important thing that it does power is this contactor. This is a contactor. What a contactor is it allows you to quickly connect and disconnect mains voltage. It's something that you need to be cognizant of when you're dealing with high voltage, how to disconnect it quickly. This contactor serves a fantastic role in doing that. What it is a giant magnetic coil, basically, that when it's energized with some type of auxiliary power, in this case my 24-volt power supply, when it is energized, it will allow these contacts to all be opened and power to flow into my whole system. The second this is interrupted, it will disconnect and suck the magnetic coil back and disconnect mains voltage in split second. That's really important safety feature that you should have in your enclosure. The way this gets turned on is not by power just flowing through. It needs to be held open. I had to do some kind of nifty rejiggering here. The reason for that is the normally spec'd contactor for the PrintNC or any CNC would be to have normally open main contacts and to have a normally open auxiliary contact. What that means is normally open, when it is not energized, it is not connected, it's open. And when you energize it is what closes it. The issue with mine is that my contacts, my auxiliary contacts, are actually normally closed, which was a problem. So I needed to find a way to make sure that they were held open or normally open another way. The way I got around this is through my front panel, and these two buttons are actually what control the contactor. So when the green button is pressed, what happens is, sorry for that noise. So what will happen, I'm not sure if you can see this, but this red wire is hooked up to those momentary buttons. So the second the momentary button is pressed, this red wire powers this contact right here. It closes it and allows power to flow back. What then happens after that is power flows around the whole system, obviously, into this open contact right here. This open contact is then connected back into the same auxiliary contact that holds everything open. So this basically is a holding or a latching circuit that I've wired up here that will hold this normally closed contact open by energizing it and allow mains power to flow through. Mains power, the 240 volt, as you can see, I have put the phase 1 in black and the second phase in white. I know that's a bit confusing because I used black for the neutral of the 120, but I didn't have that many different color wires, so I ended up using it, and it's fine. I know, I'm the only one that's touching this, so I know what it is. The phase 1 and, I guess first phase and second phase will lead into these two bars here. These two will power a couple things. They will power the 240 volt VFD as well as the spindle, and they also power the 240 volt emergency stop button on the front of the machine, which we will get to in a second. As you can see, there are a lot of wires we haven't talked about yet. It's kind of chaotic in here, but that is so far what the logic of power flow is. We've talked about the 120 volt and the 240 volt bus bars, as well as the ground bus bar, and how power flows to this VFD. One thing to note for the VFD is if you power on the VFD, be mindful of how you wire it. Power flowing in, obviously, you can see it flows in here from these over there. The three phases right here go to the spindle, and I have everything grounded with this ground red pin right there. One thing to note about the VFDs, they claim that all the contacts, I guess the screws here, are grounded. I wouldn't trust those. I would definitely try to check and use the actual pin that is grounded and says ground, and I confirmed this with my multimeter to make sure that everything is grounded. This ground serves for the VFD, and this is the termination of the ground for the actual spindle itself as well. Projects by Brian mentioned that his cable, the ribbon cable to connect your VFD to the actual display on the front, his little connector, he had to invert it, and he had to Dremel off a little piece to make it fit. I don't know if that was maybe with his model, he had a different model or something, and I've heard other people had to do that same thing in the Discord community as well. The one that I got, I did not have to do that with. It worked perfectly. I'm not sure if that's because my ribbon cable was different or if mine was the correct way. I tried to watch his video a couple times and fast forward to that part, and I think mine just might be the opposite way on my actual VFD. I don't know if he got a defect or if mine is a new version or something, but something to note about that. Make sure you get the correct ribbon cable direction, otherwise your front display will not work. The VFD control, I won't go through it. You can watch the wiki on the Discord, but when you first power it on, there are different settings you can do to test it and get it ready to go, as well as to enable the serial communication with your computer for Linux CNC. Sorry for the noise again. I connected mine to my Linux CNC computer via this Ethernet cable, I guess. It terminates into a USB. I think it's RJ45 to USB or RJS45 to USB. It was pretty easy, just an RSA or RS minus, and you plug them into these two. Pretty simple, self-explanatory. That means I can control the spindle speed both from Linux CNC and from that front panel. I'm going to use Linux CNC because I just like that better. It's all easier to do in one area, but it's nice to be able to control it from this panel if I needed to. Now that we've talked about the kind of upper half of this enclosure, I want to focus on the bottom half. The bottom half is, I guess, somewhat more complex in the logic of where things flow. In order to explain this, the first step is to explain how power gets fed to this lower quadrant here. The power from the contactor comes to these two bus bars here, and the 240 volt power, as you recall, comes from these two places. One to this VFD and then to the spindle, and the second one goes to the actual 240 volt e-stop that I have wired that we'll take a look at as well in a second. That e-stop takes the 240 volt. After the magnetic coil is engaged, it'll feed the Cisco power supply, which we'll look at. It put it back in this enclosure, and it brings in 42 volt positive. It brings in just a normal ground, which obviously is linked all the way back. It brings in 12 volt, 5 volt, and 3 volt. And I'll show the wiring I did on that in a moment. The voltages that I bring in are these small wires here. I'm not sure if you can see. And those feed in. The 3 volt and the 5 volt don't go anywhere, as well as the 12 volt is going to be used for lighting stuff later on. The 42 volt is what powers these drivers and ultimately powers the motors themselves. So let's discuss that for a moment. The black wire, as you can see, is the ground wire that comes in our neutral. That comes down all the way around and comes to this bus bar here. This bus bar then powers, or I guess is connected, not powers, connected to all of the drivers themselves. The 42 volt positive from these red wires, as you can see, feeds all the way through here, comes into these two fuses, as you can see. They're just solar fuses, disposable, removable. And then those then feed in and power each of the drivers themselves. One thing to note about these fuses, you want to wire them so that the Z-axis is on one of them with the X-axis, and you want both Y's together. The reason for that is if one of the fuses blows, you want power to be blown to the both Y's, or I guess your Z and your X. The reason we want the Y's together is if one of them blows and the other one doesn't, you don't want your machine to tear itself apart. As you can see, one would be moving, the other one would be stationary, and you essentially just tear your machine apart. So that's why you want to make sure that your Y's are on the same together. The power that feeds in, as you can see, is on these two right here, on all of them. I did not daisy chain them. That's an important thing you should remember not to do. Once power is fed in, these bottom wires, these shielded cables, then connect all the way to the actual aviator connectors in the top, and then those go to the motors themselves. The wiring of these is something that we should talk about and is mentioned before. When you wire up the motor, what you want to do is first take the motor, and I'll show this. Project by Brian does a really good example of this. You want to basically short two of the wires together and try to twist the shaft. When you try to twist the shaft with two of the wires shorted, if it's the same pole, what will happen is it'll be really hard to move because of the magnetic force that's being generated. That's how you know that it's a pair, and you want to match them up. So in my case, on this end, it was black and yellow and red and blue were two different pairs. Double shielding is important for the motors and for the drivers. This reduces the chance of any interference. As you can see, I have not wired my shielded cable, the drain to the ground. I will be doing that eventually before this machine sees any actual significant use. These drivers you're seeing pictured here are the DM556s. I originally had the DM542s. I know some of the spec'd ones in the Discord used to be, I believe, the TM6000s. Those people have mentioned are really loud. I know Projects by Brian used them and said it was too loud, and he upgraded as well. I didn't do that for any reason other than I got the DM542s, but when I hooked them all up, I had a yellow light, or sorry, green light flashing on all of them, which meant something was wrong. I did a lot of research and troubleshooting trying to figure out what was wrong. I couldn't find anything. I spent weeks trying to plug and unplug and configure it, and I stumbled upon in Discord an issue that was found, and other people experienced the same thing with the same drivers. The problem was, during COVID, the supply of electronic components was much lower, and what we found was some of the Chinese manufacturers of the DM drivers were using resistors that were rated only for 36 volts, not the 42 or 50 volts that these should be rated for. So when you supplied any power supply that was above the 42 volts, or sorry, above the 36 volts, you got over voltage error on all of them, and it prevented it from basically shorting the machine or shorting the driver itself, even though it could handle it. The people in Discord that found this issue, what they were doing is they were just contacting the AliExpress store, and the AliExpress store found the issue, understood it, stopped production and fixed it, and shipped them all new drivers free of charge. I didn't want to deal with that. I just decided I'm going to order the upgraded drivers from Amazon. I contacted the AliExpress store. They were nice enough. I had another part that I had misordered the incorrect part, and they gave me a big discount to get that part as a way of apology for the incorrect drivers. And what I found was when I then changed these out to the DM556s, I had no issue whatsoever. They were totally fine. They were the correct ones. It all worked fine. I went back and tested the DM542s, and I found that of the four, even though they were all four throwing errors, only I believe one or two of them had this issue. I don't know why. It wasn't repeatable, it wasn't consistent, but I know it was this issue because when I tested it with my workbench power supply, anything above 36 volts would trip them, and sometimes they would work, sometimes they wouldn't. So with these, I have had no issues with tripping at all, and they are being powered with 42 volts as I intended before. The way to communicate with these drivers, there are multiple ways to do it. The general way in the Discord is to use a PC that runs Linux CNC and a breakout board. The drawback of this is you need to make sure you have low latency and a pretty beefy computer that can handle that, because it's basically the one that's telling all these drivers when to make what step. Any spike in latency or causing of any lag might cause some issues with how the communication is going to the drivers in real time. For my machine, I decided I didn't want to deal with that at all. The computer I have dedicated to Linux CNC and the CNC machine isn't that beefy, and it will not be able to handle the low latency. I've done the test, and I actually have a crazy high latency on it. The way I mitigate that issue and the way that it doesn't matter at all is with this board. This is a Mesa board. The one I have here is the 7i76E. I think it's the most popular board that I've seen thrown around. I know that people use the 7i96, I believe. I went for this one for various reasons, which we won't get into, but I want to take a really close look at this board. The documentation for this board is very well documented. It's very well established. The issue I found was documentation with this board in this application was a little bit on the rocks, I guess you could call it, at the point of me doing this. I spent about another week and a half troubleshooting this thing. Some of them were really dumb noob issues that I had to go through and have people help me through, and some issues were a little bit more complex that I had to solve myself, and I wanted to share those because they're important, and I think it's something that people need to be cognizant of if they're trying to do this machine. I know a lot of people in the Discord try to use a similar board as mine with the same setup, and they had issues, and it took us a lot of time to troubleshoot together. Huge shout out to, in the Discord name is DZ, or DZ, I guess, because he's in Europe. He's been really helpful in helping me troubleshoot some things, and we've kind of been going through this journey together. So first, let's talk about the Mesa board's power. there are a couple things that are important with the Mesa board and its power. You can use this port right here to provide 5 volts to it, and the Mesa board actually accepts, I believe, anywhere from 5 volts to 24 volts to power on the board. I decided to use my 24 volt power supply, and I have power in coming in here and here. Now, the important thing here is that the power coming in is the same. As you can see, I have 24 volts and the neutral, 24 volts and the neutral, and something to note here, this is 24 volts as well. These are all powered from the actual power supply I have up in the top there, and this orange bar right here, this bus bar, this is field power. So this powers all your sensors, everything else you have hooked up to the machine. It is required for any of those sensors or any of those inputs you want, so you might as well just power it now to be done with that as well. The way you connect the Mesa board to your computer is just simply by Ethernet, as you can see over here. It's really easy, and this Mesa board's major advantage is you don't have to worry about the latency of your computer at all. The board is then connected to the drivers like so. As you saw, they were Ethernet. These are just Cat 6 or Cat 5 cable that I have wired up here, and I just made sure to wire them up in pairs. So as you can see, these 4, this is 1 motor, 2 motors, 3 motors, 4 motors, and you can look up these schematics if you just look up the 7i76E manual, this will come up. But basically, if you want to look at what I'm doing, is 1 pin's empty, 4 of them, there's 2 more pins empty, 4, and so on and so forth. You do want to keep in mind that the direction of these and on the drivers is different. If you take a look, and I'll try to show this here, the driver cable wiring here, the brown one is on top on my actual motor, and here I'll turn it around so you can see both. As you can see, the brown is on the bottom over here, but on the top over here. So those are kind of flip-flopped depending on how you put the driver direction. You could easily change this if you wanted by just flipping the direction of your drivers themselves. I didn't do this, but you know, something to note. What we should talk about are the sensors. As you can see, I have 4 pins here. These 4 are all the sensors for my Z, my X, and my Ys. These are the actual data pins, I guess you could call them. You have 24 volts coming in here, 24 volts coming into field power. The field power out, I'm powering from here all the way up to this bar up here. These 2 are the actual ones being used for 24 volt separation. The 24 volt distribution bars here are connected to the sensors here, with the data pins going down to the Mesa board at the bottom here. I originally did the power for these end stops with 12 volt from the Cisco, and I had some issues. What I realized, and this might be something that wasn't unique to me, I know DZ had the same problem, when the power voltage is not the same as the board is not able to distinguish it. And what I realized was the induction sensors use a voltage difference to determine whether they are activated or not on the receiving data pin end. So when you power them with the same power the Mesa receives, at least from mine, that was when I had this issue fixed. If I used any other voltage than 24 volt or close to 24 volt at the very least, the Mesa board wasn't able to distinguish when those sensors were being triggered. One thing to also note, the numbering of these pins on the bottom here, these are the input pins for any sensors and stuff you want to input. The first 3 are reserved for, I believe, analog sensors. If there's 3 or 4, that's something you should remember when you try to wire this up. Other thing you should remember too is that the numbering, I believe, starts at 0 and goes up. Whereas on Linux CNC, the pin numbering starts at 1. It's either that way or vice versa, I don't remember. But one of them starts at 0, the other one starts at 1. So whereas on the Mesa board, this might be pin 7, on Linux CNC, it would be pin 6. In Linux CNC, it's just as easy as just numbering these as the end stops or limit switches for Z, X, Y, and X, or however you want to do them. I believe I did mine in order of X, Y, and Z. So now I want to talk about this top panel up here that all the inputs are. For those of you that have OCD or are big wire management people like me, please don't judge me. I will be organizing this and building some cable holders here to hold this upright. I haven't got to it yet. I know it looks like a mess. Just bear with me, please. As you can see here, I have one connector that is not being used. This is a 45 that is not being used right now. I'll be using this for a pendant later on. That's another project for another day. So for now, I'm just keeping it closed so nothing gets in there and ruins it. This one is the Mesa connection in. So the Ethernet from the bottom feeds into here, and this connects to the computer itself. As you can see, it's labeled in the back. These are the actual motors that are fed out. These are just aviator connectors that I wired myself. We'll open them up. You can take a look. They'll be in the video, but they look normal like that, and they terminate through like that. The actual sensors, as you can see, are also here listed. They're, X-Max, Y-Min, Y2-Min, and the Z-Max are all listed here, nice and clean. These two flanged outlets in the back, these are the actual, this is 240 volt in, and this is the 120 volt in. These are flanged and nice waterproof connectors. I'm losing almost all waterproofing because this is printed in 3 panels. My printer wasn't big enough. This came with a metal top panel. I didn't want to cut all these things and label them, properly. I didn't think I could get the holes proper for all these and everything. So I just 3D printed it with trial and error. It's good enough for now. Eventually I will use the CNC machine to cut out all these holes exactly properly, just using this template, and you can obviously have that as well. I will be putting the 3D model, the STLs for these, as well as the CADs on my Thingiverse. The benefit there is, you can use these and modify them to however you like. These are just made for my enclosure itself. If your enclosure is different, I take no responsibility if the holes don't line up, but with the CAD, you should be able to edit it as you like. As you look on the left-hand side here, I have 2 of these outlets. One of them is used for my water pump, and the other one is probably going to be feeding the shop vac / air compressor. I haven't figured out how I'm going to do that yet. I'll probably have to wire this out to a little box or something and then connect it from there. This right here, this corner right here, this is the spindle out. So it comes from the VFD into this, this cable gland, and this is the actual thick cable that runs into the spindle itself all the way through the machine. The thick cabling right here, as you can see in the back here, this is what feeds directly into the 120 volt e-stop here. This is a magnetic e-stop that I got. So what that means is, and I'll adjust the camera here, what that means for that e-stop is when power is cut for any reason, so if there's a power outage or anything like that, the magnetic coil will not engage again, meaning power will remain off until somebody presses that little tiny green button to turn it on. This one is a 120 volt one, and the second one back there, that is the 240 volt one. They are both the same. So from the second e-stop over there, which we'll show in the front, that feeds into the Cisco, and we'll go back around and show that side there. Going back to the top board panel here, I think we've described everything. The one thing that's missing is this cable right here. This cable is the RJ connector from my computer to the enclosure itself. All these wires all run kind of in this direction, and as you can see, they kind of all feed up into the side here, and they go up into the actual enclosure itself. This is the next view that is useful here to see. As you can see, this is the 240 volt e-stop that is wired here. You saw the back of this one. The output of this is the Cisco power supply down in the bottom there, which then feeds into the motors. As you can see, I have a kind of a old Dell here that I salvaged that was trashed before, that was operating here. Shop vac that should be plugged in there, as well as the water cooling back there. We'll talk about the water cooling in the next video, I think. Some important stuff to talk about there, as well as the rest of the machine. So now that we've talked about kind of all the wiring that's gone into this and the electronic portion, the only thing left now is to show you the start sequence of my machine. So the first thing is 120 volt turns on. That turns on the lights, as well as the Mesa board turns on. Without powering on, I press that button. That will turn pretty much everything else on. In here, as you can see, the VFD went on. Everything is being powered on. What I could do next is then I will turn on the water pump. I will turn on the shop vac, but I don't want to turn that on very loud. And then if I engage the 220 volt or the 240 volt, the Cisco turns on, and that is the start sequence of my CNC machine. Turning it off is just as easy, the same thing. Slap the Cisco off. I can then turn off that if I wanted. I could kill all power here, turn off the contactor, kill all power. In the next video, we'll be talking about all that crazy stuff. You might be able to see it. I am kind of teasing it here a little bit. It is not ready to show you guys yet, and that'll be the next video. Tune in next time. Thank you so much for watching. Bye-bye.